As always, the key to solving this problem is going to be to understand physically what's going on. There's a reaction that occurs that releases heat, and this heat goes into a sample of water, and the water warms up. So the question is essentially asking, what is the change in temperature of the water? In order to calculate that, we need to know how much heat is involved in this reaction. And to determine how much heat is involved, we're going to use this thermochemical equation. It's a balanced chemical equation, and it also includes the amount of heat associated with the equation. We're going to use that as a conversion factor. Now, before we set up our actual solution, let's notice that in this case 2 moles of this hydrocarbon is associated with this amount of heat. And also notice that the unit of heat here is given in kilojoules rather than joules, so we're going to have to involve the conversion between kilojoules and joules. Alright, so here we've done that calculation. We start with the measured number of moles that's given to us in the statement of the question. We take note of the chemical that's being used, and then we're going to use our thermochemical equation as a conversion factor. So we have this number of moles of our hydrocarbon, and our conversion factor is based on 2 moles of the hydrocarbon releasing this amount of energy. And we use our kilojoules to joules conversion factor, and we determine how much heat is released. So here we are in the problem. We know how much heat is released, and now we want to calculate what the final temperature of the water is. So we need a delta T that we can add to our initial temperature to determine our final temperature.